Snow. It could be nature's most curious riddle. A dream answered for some, a nightmare relived for others. It can cover the countryside with a soft blanket of serenity, or blow with a blind fury that cripples commerce and industry. A riddle containing both power and beauty. Some anticipate an approaching snowstorm with the same fervor as Santa Claus or Christmas Eve, traveling long distances at great expense to play in the snow. For all those who flock to it, you find just as large a population who run from it, seeking shelter down south. Snow removal replaces snowmaking. Urban areas spend hundreds of millions of dollars removing snow from sight. Cities spread on streets 8 million tons of salt at a cost of more than $250 million. Snow has the potential to nurture and destroy. In much of the Mountain West, 60 to 75% of annual precipitation falls in the form of snow. But snow can also flood fields and cut crop yields, collapse roofs, and tear down trees. It can ground air travel and send the morning commute into a spin. The negative power combined with the innocent beauty makes the job of the weather observer invaluable and challenging. We measure snow to describe it and compare, study, and prepare for it.
Consistent time of observation, consistent measurement practice on your snowboard is absolutely vital in order to get an accurate and precise information on how much snow has fallen and how much snow is sitting on the ground. So for climatologic purposes, we can understand the climatology of snow, and in terms of climate change, we can understand the variability of snow through time.
The importance of accurate and consistent measurement of snow cannot be overstated. Information gathered helps to compare one location to another for a particular storm, for a winter, and for long-term differences in average snowfall. It's also used to track long-term, year-to-year, and decade-to-decade changes. Observers gather information on precipitation, new snow accumulation, and total depth of new and old snow and ice on the ground. Precipitation includes the water content of the snowfall, plus any other moisture that fell in the previous day from rain, freezing rain, ice pellets, or hail. Snowfall is defined as the accumulation of fresh snow since the last observation. Snow must be measured on a snowboard or appropriate surface, such as a backyard picnic table, as long as there is little drifting. Snow depth is the total accumulation of both old and new snow and ice measured on the ground.
Well, one of the essential ingredients in taking good snow measurements is finding a good representative location to take those measurements, and one of the best times to think about that is before it snows. And so we're in a typical backyard here, and we're going to look at some of the issues that you need to deal with in terms of finding a good place for your measurements. Got a snowboard here, which is a key ingredient for getting a good start for snow measurements, and we're on a deck. One of the most common places that people like to measure snow is right out their backyard, and a deck is a very convenient place, but there's a reason why we don't recommend it. And if you look here, what's close to the deck is the house. And here we're looking at a two-story house. Typically in snow, you're either going to get more accumulation. If the wind's coming from this direction, it's going to sweep down along the side of the house, and you're going to get more accumulation here on the deck. Or if the wind's from another direction, it's going to blow off the roof down here on the deck, and we're invariably going to have more accumulation here than actually fell. So this isn't where we want to do our measurements. We are going to look at the critical issues that we have to deal with, which are typically obstacles, convenience, because we do want to be able to get to our measurement site quickly, and we want it to be somewhere where there's not a lot of traffic in the backyard, but where it's a convenient access but not obstructed. Also want a level exposure, as level and horizontal as possible, and then we've got a good start. Well, I think I've spotted a good location in this yard. Our obstacle here is the fence, about 6 feet tall. We'd like to be 10 or 12 feet away from that, but still be as far away from the house as we can, and from our big obstacle over here, the tree. Looks like this is a good distance. We're going to call it right here. We're not too far from the door, not in a traffic pattern, nice level grass, good open exposure, this is going to be the site for measurements here. The tools for measuring snow are very simple. We've got our rain gauge consisting of the funnel, the inner measuring cylinder, and the large overflow can. What goes with that? The calibrated ruler specifically made for that rain gauge. Then all the other equipment we have is a basic ruler, increments in 1/10 of an inch, and our snowboard. Some observers will be equipped with just a 4-inch plastic rain gauge. Not quite as big, but the same concept. Funnel, inner tube, overflow can.
Let's look at taking measurements under ideal conditions. An accurate reading of the water content is very important. When the winds have been light, the gauge will catch most of the snow that's fallen. At your scheduled observation time, bring the overflow can inside to melt the snow. The primary method is to melt the snow with warm water. First, pour warm water into the inner measuring tube and measure with a calibrated dipstick. Make sure to note this amount.
1.13 inches.
Then, pour the warm water into the gauge and slosh it around to help melt the snow.
Melting.
Pour this back into the inner measuring tube. Use the funnel and support the tube carefully so none of the contents spill. Measure the total amount and then subtract the quantity of warm water. The remainder is the amount of precipitation for the day. Measure the water content to the nearest 1/100th of an inch. An optional method involves setting the gauge in a bucket of warm water. It may take a little longer to melt. The quickest way is to pour warm water into the catch.
So let's review the measurement of precipitation. One of the most important things we do is get an accurate reading of the water content of the snow. To begin with, you want to get your funnel and your inner tube inside before snow arrives so we can get a better catch. Then, after we've had the snow, we're going to have to bring the gauge inside when it's time for your observation, so we're going to melt the snow. Now you can let it sit there, but it's going to take a long time to melt. So we can either put it in a bucket of warm water, but even then it takes a long time. So what we recommend, because I'm usually in a hurry, I don't know about you, but add water to your calibrated tube. You're going to have to measure that amount so we know how much warm water we're adding. Pour it in, slosh it around so that we get all the snow melted. Then, putting the funnel back on top of the tube, pouring the total back into the gauge. Then, using only this kind of dipstick, the National Weather Service standard rain gauge dipstick, a regular ruler doesn't work. Measuring the total amount, then subtracting out that amount of warm water you added, so then you know just how much water content was in the snow. So then we're in business. Now don't forget, when you're all done, get that gauge back outside so that you're ready to catch your next snow.
Use good judgment. Not only does it matter what and how snow is measured, but it also depends upon the finest details of when and where. The difference of an hour or a distance of a few feet may be as great as taking the measurement in an entire different county. Snowfall is the measurement of new accumulation of snow, ice pellets, and hail, but not freezing rain since the previous day. Place the measuring stick straight down in the center of the snowboard. Measure to the nearest 1/10 of an inch. Double-check your measurement by sampling several places and averaging the totals. After completing the measurement, completely clear the fresh snow and ice from the snowboard and place it back on top of the snow. If you don't have a snowboard, measure on a representative level surface. Remember, snowfall on a grassy surface can actually be supported in the air by the grass, giving unrealistic measurements.
So let's review the measurement of snow. You want to measure it on a snowboard or another good surface like that. Now if you've got a snowboard in your yard, don't be caught off guard by a big snow. You want to have a flag, something to mark it so you can find it when you do have that surprise snow. Now, if the snow accumulates unevenly, or if you've got drifting in your yard, you're going to want to take a measurement of at several locations and get an average. Average, measure to the nearest tenth of an inch, and then don't forget, right at your time of observation, clear that snowboard and get it back on the surface of the snow so you're ready for your next measurement.
The total depth of frozen precipitation on the ground consists of the new snow plus any old snow and ice that remain on the ground from previous storms. Report this measurement to the nearest whole inch. This includes the depth of hail, ice pellets, and glaze from freezing rain. Measure the total depth of snow on the ground in an open, undisturbed, and relatively level area free from drifting and premature melting. If necessary, take an average of several readings. With no previous snow and no melting or settling, the total depth of snow on the ground is identical to the amount of fresh snow that's accumulated.
Snow depth is both the old and new snow on the ground, including ice, and you want to measure it right at the time of observation. Take an average if there's variations in the depth, and there often are. If part of the ground is covered with snow and part is bare, you still take an average, including those bare areas. But if the majority of the ground is bare, then all you need to do is report a trace. Do report depth of snow on the ground, even on days when no fresh snow has fallen, and just do your best.
Conditions seldom resemble ideal. Snow melts and settles, and the wind blows. Sometimes snow changes to ice pellets, freezing rain, or just regular rain. Adverse conditions make it more difficult to make accurate, confident observations. The biggest enemy of accurate observations of snowfall and water content is wind. Winds will drift one area and lay another bare. The moisture in the gauge may only represent a portion of what actually fell. Under extreme wind conditions, perfect measurements will never be possible. Precipitation gauge undercatch is often a big problem for open, exposed gauges in high wind conditions.
Two things happen when we've got winds accompanying snow. First of all, obviously we get drifting, and that means we're going to have to take averages of the snow accumulation. But secondly, we've got the problem of gauge catch. When there's wind-blown snow, you're not going to catch everything in that gauge. That may mean the need for taking a core sample.
If winds have been strong and you believe the precipitation in your gauge is significantly less than what really fell, then take a core sample of the fresh snow from a representative location. If possible, take this core from your snowboard. Melt and measure the sample and compare it to the moisture you measured in the gauge. Report the most realistic reading and make note of the source on your form.
So remember, if it's been windy, you may have to take a core sample to get a more accurate reading of the precipitation. Take that sample at a location where the depth of fresh snow is about what the average is for the area. It may be a little bit awkward and difficult to take this reading, but it really does make a difference for the quality of data we collect.
Another factor that makes the measurement of snow difficult is the fact that snow melts and settles. Therefore, measuring snow can be like shooting at a moving target. When dealing with melting snow, measure often enough to note the greatest accumulation prior to melting and settling. The effects of strong winds are obvious and visible, but subtle processes like melting and settling also pose a challenge to weather observers. Depending on temperature, sunshine, wind, and the type of snow, there will usually be a certain amount of settling or melting. When measuring snowfall, the goal is to report the maximum accumulation of fresh snow before it melts or settles. When it's cloudy and temperatures are well below freezing, there may be no melting or settling. But often the snow depth decreases quickly as the storm diminishes or changes to rain. Let's illustrate how to report during these conditions. Assume your normal observation time is 7 a.m. A storm moves in shortly after your morning observation, and snow accumulates steadily from 8 a.m. until the storm suddenly ends at 2 p.m. Then the sun comes out, the temperature warms, and the snow both settles and melts, so that by the next morning there are only 3 inches left on the ground and snowboard. What should you report for your daily snowfall and your depth of snow on the ground readings when you measure at 7 a.m. the next morning? At your observation time, the snow depth is clearly 3 inches, so that is what you must report for snow on ground at observation. But you should report 6 inches for your 24-hour snowfall amount, since that was the accumulation before melting and settling. Let's look at this illustration again. Report the greatest accumulation of fresh snow to the nearest 1/10 inch as your snowfall total, and report the depth remaining on the ground at your regularly scheduled time of observation at the nearest whole inch as your at observation snow on the ground report. Of course, don't forget to measure and report the water content that accumulated in the overflow can of your rain gauge. If snow melts immediately and never accumulates to 1/10 of an inch or greater, report a trace for your snowfall amount and record 0 for your depth at time of observation. If you experience a series of snow showers where snow accumulates but then melts before the next shower arrives, report daily snowfalls as the sum of the maximum accumulation from each shower. Do your best and report your uncertainty.
When we're measuring the total depth of snow at the ground, that's easy. We measure it right at the time, at your scheduled time of observation. But when we're measuring snowfall, what we're really trying to measure is the most accumulation that we've gotten during the day before it begins to melt or settle. And to get the best measurement of that maximum accumulation, you might have to read before your standard observation time. You may want to read it right as the snow is ending, diminishing.
In some parts of the country, particularly the northern states, and in mountainous areas, some observers will be requested to report snow water equivalent. This daily or weekly measurement is very important to hydrologists, flood forecasters, and water supply planners. This is simply the total depth of water in a sample containing all old snow plus any new snow that has fallen in the past 24 hours. To measure snow water equivalent, find a location where the current snow depth is close to the average snow depth on the ground. Place your 8-inch diameter overflow can and press it straight down until it cuts a core sample to the ground. Brush excess snow away to the outside and make sure all the snow and ice from the core remain in the gauge. Then melt the sample by adding measured amounts of warm water. Continue like any precipitation measurement, being careful to subtract out the depth of warm water you added. If you have deep or very icy snow, it may take large quantities of warm water to completely melt the core. Always check to make sure your observation is reasonable and consistent. An alternative method is weighing snow samples with a set of special scales provided by the National Weather Service. Here's a list of tips that will help you be accurate and consistent. If possible, use a snowboard for a consistent accumulation. When you clear your snowboard, place it gently on the surface of the existing snow cover. When measuring drifted snow, measure in protected areas if possible. Take an average of as many readings as necessary to get a reasonable and representative estimate of both the fresh snowfall and the total depth of snow on the ground. Ideally, all observations should be taken at the same time each day, but it sometimes may be prudent to read when the snow ends. Cooperative observers usually measure once per day, but observers may take snowfall measurements as often as every 6 hours. Measuring and clearing snowboards more frequently than this is not acceptable, as snowfall totals could be inflated. When melting and measuring frozen precipitation, pour carefully and avoid spilling. Don't assume a particular snow-to-water ratio. It will vary from storm to storm. 10 inches of snow does not always contain 1 inch of liquid water. In low humidity climates, keep in mind significant evaporation losses can occur. In these cases, it may be best to measure soon after precipitation is ended. Be on the lookout for rain gauge leaks. Have a backup observer in the wings in case you can't be around, a neighbor, a relative, someone who lives nearby. Report precipitation to the nearest 1/100th of an inch, snowfall data in inches and tenths, and snow depth to the nearest whole inch. Record data on forms provided. Be accurate. Make sure you enter the right information in the proper column. You've been patient up to this point, so don't rush. Make use of remarks to describe your observation. Remember, people may be using your reports generations into the future. If you're asked by the National Weather Service to report snow water equivalent, also enter this on your form with remarks.
Accurately recording your observation is just as important as taking an accurate observation. Keeping in mind you need to make your entries legible on the form so it's easily read by other people. The precipitation is entered to the nearest 1/100th of an inch. The snowfall is entered to the nearest 1/10th of an inch, and the snow depth is entered to the nearest inch.
Finally, don't be caught off guard. Get your snowboard out before the first snowfall and bring your funnel and measuring tube inside.
Good luck with your snow measurements. If you have any questions, please contact your National Weather Service representative or take a look at the copy of the snow measurement guidelines that they've provided.
Simply put, our co-op observers are the eyes of the National Weather Service. Even though we, the National Weather Service, have various types of equipment such as radar and satellite pictures, there's really nothing more important than ground truth information.
The raw power and unblemished beauty of snow creates a range of emotions. Sometimes it paralyzes. Sometimes it sets people free. Innocent and savage, this life-giving resource can sometimes be difficult to corral. The constant remains the need to maintain watch over this mysterious and challenging force. Elusive and dynamic, chaotic and serene. It's up to you to help us understand one of nature's most complex and beautiful riddles.